Hi there, my name's Jim, this is my shed and you're welcome to it. Hello there. As promised in the last video, we're going to be looking at the work I've been doing on my gearbox over the last couple of weeks. Although when I started editing the footage together, I realised it was going to be far too long, especially as at the end I wanted to incorporate a little classroom session on gear ratios, power bands, how they interact, and show what the final gearing is going to be like with my setup. But as I said, it was going to be far too long, so I've decided to split it into two parts. So this will be the first part, but as all the footage is shut, it shouldn't be too long before I get the other one out. And as luck would have it, I've actually sold the engine and all the other parts, the existing parts out the car. So over the next week, I've got to strip all those out for them to be collected. So there'll be footage of that as well to go. So should be quite a bit of footage over the next couple of weeks coming out. But without further ado, let's crack on. So, gearbox, here we go. First things first, we need to get all the bits off it that I'm not going to be using. So just a bit of stripping down to start with. Whoops. Alright, now we're getting close to being inside the box. I think now's a good time to explain the possible difficulty I've got making linkage for this. Now I know I said before that I may well go to cables, but I really don't want to do that. I like to make a mechanical linkage, so I'll just show you the problem with that. So the way the gear linkage works is when you move your gear lever, there's a couple of bell cranks that operate rods through to here. So this one moves the selector in and out, and this one is the one that actually engages the gears. 1, 2, 3, 4, 5, and reverse. Now if I just connect this direct to the gear lever, because of the way round it works, when I move the stick backwards and forwards, I won't be engaging the gears. Yeah, so my gate, instead of being 1, 2, 3, 4, 5, it will be 1, 2, 3, 4, 5. So I've got to make the rotary movement on here becomes the in and out movement on here, and then the forward and backwards becomes the rotary. So I've got to flip it around, and it's not the end of the world, but it just takes a bit of thinking about. And another problem, if you see here, we assume that's roughly level. That's roughly level with the top. This is coming out at about a 30-degree angle pointing down. So any rod that comes in this way will be pushing at an angle. So any linkage will have to operate from down here. Just all things to think about. But I think I like a challenge. So I'm going to get rid of this part of the linkage, lose a bit of weight, never a bad thing. Blank this hole off and just do everything on this linkage here, probably using something like these UJs that I bought. They're a bit on the beefy side. I'll probably take a bit of weight out of them before I use them, but if I modify, put something on the end of that shaft to take that will fit on there, and then my gear linkage can come in and operate through something like that. I've got a couple of these. Why not make use of them? Right, let's get inside the box. First of all, we need to take the diff out. 1773. It's about a 4.3, something like that. Right, now those gears are locked together. look at the condition of these forks. I'll use whatever's best out of all the ones. I'll choose the least worn ones, obviously, to put it all back together with. As I've said, I'm not going to be using this part of the linkage, so this bit can come off. And those are the bits that I want. Now obviously before I put this together, I do need to clean it up a bit, because even I'm not going to leave it looking like this. The best way to do that would be to get it vapor blasted, but that would involve paying someone to make my gearbox look better, and I'm not really into that. So I'm going to attack it with a Scotch-Brite, just get the worst of the surface off, and then when it goes in the parts cleaner at work to get all the grease out and get it all nice and clean, it should come up lovely. So let's start rubbing. There, done. And before anyone accuses me of being crazy, I'm not that stupid. So off camera, I got this all degreased, and I used the press at work to take all the gears off the shafts. I couldn't video any of that because it wouldn't go down too well me videoing a workshop, but there you go. A word of warning for anyone who does ever strip one of these gearboxes down. It all came apart fine, everything pressed off nicely until the last bearing that sits right next to this gear. Pressing away, thought, that seemed a little bit tight, and it seemed very tight until the bearing exploded, and on closer inspection there's a circlip that sits underneath it and retains the gear. Pop the circlip out and it pulls straight off. I've no idea why that circlip is there. It doesn't do anything. I can only imagine it's there for assembly purposes to stop the bearing falling off at some part during production. Doesn't do anything once it's all put together, so I'll be leaving that bit off. The other jobs I need to do before I put it all together are I need to make a bung to blank this hole off for whether I'm deleting that part of the selector, and I've got to make the piece for the end of the gear change shaft to take this UJ. So a bit of measuring up, a bit of work on the lathe and some welding even, and we'll be there. So this is around about anyone who thinks this lathe looks kind of antiquated would be right. I think it actually is an antique. Funny story about it, actually was rescued from a prototype, electronics prototype workshop at a factory in about 1960 that my stepdad used to work at. I think we finished his apprenticeship and then had that when they closed the workshop down. Sat in his garage for a while. I think he reinstated it in about the early 80s, so I've been using it for 40 years. And it is old, and you can see here, yes, that is me oiling the bearings, but it does its job as long as you're careful with it. Bit of chatter here and there, but as I say, if you're careful, it can do perfectly good work. Got to cut that bit off there, then turn that down to fit inside that, and then weld it on, and good to go. So here you can see I'm trial fitting the piece I made to go on the end of the shaft. Nice snug fit, so perfect for welding on. And here I am. I didn't get too close up with the welding because I'm not sure how the camera will react to that. Maybe I'll experiment with that in the future, but it's just a little single phase 200 amp TIG welder I've got. And here I just touched the tungsten onto the workface, so had to take it off and give it a quick grind. And now that I'm done with the welder and the lathe, I think it's time for a beverage. Cheers, good health. That's better. Now I've got everything degreased, my nice clean assembly area ready. Let's start putting it all together. So here I'm just using a drift to seat the first bearing nicely. And as we're going along, I'm just lubricating all the parts, all the moving parts anyway, with just some fresh gearbox oil I've got. And once things are oiled, just give them a quick spin to make sure the oil's all evenly distributed around, there's no dry spots anywhere. And then just more of the same, using various bits of alloy tube as various drifts to make sure all the different parts are seated down properly on the shaft. At this point, I'd managed to convince myself that when I stripped all the gear sets down, I'd managed to mix up the gears so I didn't have the right ratios. So just seating them next to each other to make sure that I had in fact got matching pairs. I needn't have worried, but it's just a bit of OCD creeping in and convincing myself that I must have got something wrong. And there's another job jobbed. So enough lubrication of the gears, a bit for me. We'll bag those up and call it quits tonight, I guess. Before I really start putting it together, I thought I'd quickly go over how a gearbox actually works. Might be of interest to some people now that it's all apart and in bits. You don't often see them like this, so I thought I'd just go over it. Right, so what we've got input shaft, clutch here. So when power comes from the engine into the gearbox through this shaft, it then goes through the gears and out through this shaft to this one, which is the final drive, which is then connected to your diff and onto your wheels. Now the way it selects different gears is there's 4 on here. The fifth is here. Bolts on the end, but we'll just go through the 4 for now. So of all the gears, they're constantly, it's called a constant mesh gearbox. So every gearbox made after about 1930 would be a constant mesh. All the gears are always meshed together. Of each pair, so on this shaft, this one is connected to the shaft, obviously. This one's connected to the shaft, but then you see these two are free to spin, okay? And then on this shaft, obviously, where these two are fixed, so the first gear is free to spin, second gear free to spin, and all the others are fixed onto the shaft, okay? So what we need to do is, you can see when it's together, there's no gears engaged, the input shaft can spin freely. So that's you in neutral, foot off the clutch, and this is just spinning away, catch the engine, and no power's getting through the final drive. Now what we need to do is, whichever gear you want, you need to connect the gear to the shaft. So just say we're going to connect first gear, what we do is we slide this collar here along, some bits engage, click like that, and then you'll see that those two are fixed and you're now in first gear. So power comes in here, through the first gear and in that. When you want to change the second, you swap to this one. So now this pair's engaged, that second gear is now driving the shafts, and you just go on through. So you want third gear, you come out of there, comes third gear, and then into fourth gear, and then obviously fifth is this pair that's not bolted on the end yet. The way it changes is, these are called Selector Forks. So these are made of brass, and obviously they've got a slide inside these slots as they're spinning, so that's why they're made of brass, they don't wear. And all the selector mechanism does is chooses which one of these you want, and then literally slides it up and down the shaft. So this is the first and second gear. So when it's on here, that'll be connected on like that in the gearbox. That'll be on there. This will slide up and down and select, as I say, slide that one. That would be selecting first gear, and then obviously come on, and then that would be second gear, and onwards up the box. When you're actually sliding these into mesh, what's happening is, here's the actual gear that can spin on the shaft. Some splines in the middle, so that's what's actually locking it to the shaft, and you can see this slides in and out on here. Now this is called the synchro, and you'll see what it does in a moment. So when you come along, you want to engage this gear, so your selector fork pushes on here. This section here, which is called the synchro, I'll leave that for now, called the synchro, pushes into this cone in here, and that synchronizes the speed. So it grips on the gear and makes sure they're spinning at the same speed, so that we push on here, our selector ring, our selector pushes on here, the synchro engages, synchronizes the speed of this gear to the shaft, so that can go click, and it's then all locked together, and that's now feeding power through the shaft and out the gearbox. So when your synchros are worn out, it's this thing that wears, and it can't then grip onto here and make them spin at the same speed. So when they're worn out, you're then trying to ram these together when they're at different speeds, and that's why you get a crunch when you try and go into gear when your synchros are worn. Now the selector mechanism that I've talked about quite a lot. All that does, if you look in here, this is our selector shaft. You can see where the bit I've made to take my universal joint. This merely feeds into the gearbox, and this little tab here, as it moves up and down, that's what engages with your selector forks and moves them up and down. So if you see here, they're in line with each other. So as you pull the gearbox out, you're engaging in this one, you move this shaft. When you move it in, you move this shaft, and then when you move it in again, you move the third shaft, but it'll be the fifth gear and reverse gear in this gearbox. And there you have it. Reverse. This gear is very basic on this gearbox. This large fork here actually takes the whole reverse gear. Drop the reverse gear in. You can see that when you're trying to engage reverse, what you're doing is physically sliding that gear up and down. What that then is doing is, because obviously to go backwards you need another gear so that they spin the other way round. That's engaged in this gear here and it's sliding up and down. So you can see if it's here, it's not engaged, then it slides along, meshes with this gear, which is the reverse, and that gives you reverse. Also in this gearbox, straight cut, which is why you get that horrible whine when you go into reverse. And also there's obviously no synchro or anything, so these are the best ones I've got out of the bunch. But you can see where if you haven't got your clutch fully depressed, or you're still moving slightly when you try and engage these and they're spinning at different speeds, you're going to get a lot of graunching going on this edge. So that's that you get when you try and engage your reverse gear when either your clutch isn't in or your vehicle's moving forward still. Now I hope that made it clear. Any questions? please feel free to ask. And that's where I'm going to have to leave it for now. I hope that, as I said before, I hope the explanation was clear enough. And if there's anything anyone wants to pull me up on, or information you can share with me, or anything you want clarification on, please ask. All questions welcome. So, see you soon. Next video will be out in a few days, I should think, with the little classroom session I mentioned earlier. So, take care. Ta-da.